Hello all, this is Masth Electronics. Today, we will see how to interface STM32 microcontroller with OLED display. Let's go through the components required. Breadboard to build the circuit. Jumper wires to make connections between the components. STM32F411CEU6 microcontroller, commonly known as Blackpill, which forms the brain of our project. GME12864 OLED display is a 128x64 pixel display that supports high contrast monochrome graphics. Nucleo F411RE development board for flashing the Blackpill. It simplifies programming and debugging through its onboard ST-Link interface. You can also use only ST-Link, which is also available. This is LM317 variable voltage regulator, which is set to 5 volt. You can also take fixed 5 volt regulator. This is used to power Blackpill. Let's go through the circuit diagrams. Before that, we will try to understand breadboard to do connections. A breadboard is a solderless device for temporary prototype with electronics and test circuit designs. Most electronic components in electronic circuits can be interconnected by inserting their leads or terminals into the holes and then making connections through wires where appropriate. The breadboard has strips of metal underneath the board and connect the holes on the top of the board. The metal strips are laid out as shown here. Note that the top and bottom rows of holes are connected horizontally and split in the middle, while the remaining holes are connected vertically. Note how all holes in the selected row are connected together, so the holes in the selected column. The set of connected holes can be called a node. To interconnect the selected row, which is node A, and column, which is node B, a cable going from any hole in the row to any hole in the column is needed. Now, the selected column, which is node B, and row, which is node A, are interconnected. This is how we can use breadboard. Let's see the connection between Blackpill and OLED. Ground of OLED is connected to ground of Blackpill. VCC of OLED is connected to 3.3 volt of Blackpill. SCL of OLED is connected to PB6 of Blackpill. SDA of OLED is connected to PB7 of Blackpill. You can take the screenshot by pausing the video here. Next, let's go through the connection between Blackpill and Nucleo. Ground of Blackpill is connected to ground of Nucleo. SCK of Blackpill is connected to SCK of Nucleo. DIO of Blackpill is connected to SWDIO of Nucleo. This is required only for flashing Blackpill. You can take the screenshot by pausing the video here. Now, it's time for wiring the components. Let's take the breadboard for building the circuit. Connect Blackpill and OLED onto the breadboard. To power Blackpill, let's take 5 volt regulator. Here, we are using variable regulator. Connect input with 12 to 24 volt AC. You can get adapter for that. Vary the pot to fix it to 5 volt. You can use multimeter to measure voltage. Connect 5 volt output to Blackpill. Now connect ground of OLED to ground of Blackpill. VCC of OLED to 3.3 volt of Blackpill. SCL of OLED to PB6 of Blackpill. SDA of OLED to PB7 of Blackpill. Now let's do the connection to flash Blackpill. Take Nucleo. Remove the jumper wires from these two pins if connected. Connect ground of Blackpill to ground of Nucleo. SCK of Blackpill to SCK of Nucleo. DIO of Blackpill to SWDIO of Nucleo. Now, connect one end of mini USB to Nucleo and other end to your laptop. Okay, we are done with the connections. Now, let's jump into the software part. Here, we are using STM32 IDE. You can download the software for free from STMicro webpage. Link is available in the description. Once we open STM32 IDE, let's log in here as well. It's required to log in to get driver packages and firmware updates. Now, let's create new project. Go to File, New, STM32 project. Now, the required packages will start to download. We will get a target selection window. Here, we need to select the board we are using. So here, let's select STM32F411CEU6 and click on Next. Enter the project name. Let's enter as STM. Interface with OLED and click on Finish. And here we can see the pinout and configuration window. As we saw in the circuit diagram, we need to connect SCL to PB6 and SDA to PB7. So, let's configure PB6 and PB7 now. Click on PB6 and select I2C1 SCL. Click on PB7 and select I2C1 SDA. Then, go to Connectivity and select I2C1. Select I2C in I2C mode. Go to Parameter Settings tab and select I2C Speed mode, as fast mode as OLED display require continuous update to refresh the display content. Now save the configuration. It will ask to generate the code. Select Yes. The code will be automatically generated according to the configuration. The interface code for OLED is already available in Masth Electronics GitHub page. Let's head into GitHub page and download the code. Unzip the downloaded folder and then go to INC folder. Select all files, drag and drop the files into INC folder inside Core folder, which is available in Project Explorer. Select Copy Files in this window. Again come back to Unzipped folder. This time let's select all files in SRC folder and drag and drop to SRC folder in Project Explorer. Select Copy here as well. Let's see how to interface. OLED. Open main.c, Here first we need to include all the required header files such as stdio, animation, bitmap, fonts and STM32. Let's try to display some text on OLED. The actual coding starts from here. First we need to initialize OLED, which is STM32. Open STM32.h to fetch required functions. This is the function which is used to initialize OLED. Copy this function and paste it in main code, that is main.c. Now let's move the cursor to the location 10,10. For that let's search the function in the header file. Use this function and pass xy coordinates, which is 10,10. Use this and pass the text to be printed, and font size which is already defined, in font header and text color. 1 for white, 0 for black. I will add my channel name as the text here, in 2 lines. You can add whatever you like. Use update screen to display it on OLED. So we have finished the coding. Make the connections as shown earlier, to flash the code by clicking the play button. While uploading the code, we can see the LED blinking. After successful upload, blinking will stop. Thanks, everything went well. The display shows our desired output. We will go through all the interfaces of OLED in upcoming videos. Hope you understood the process and enjoyed this video. If you liked the video, give a thumbs up and subscribe to our channel for more such interesting things. Share your thoughts on this in the comment box. And if you want to learn anything new, please do let us know. We will try to cover that in our upcoming videos.